This is our UAV, with the mission to retrieve important items in the danger zone. We believe this UAV will be useful in the future. For the last 7 months, there has been good progress made by CAKSA. We consistently conduct mission research and develop a technology that focuses on SAR activities. The mission carried out by the UAV will be divided into two different areas, the danger zone and the safe zone. First, the UAV that takes off from the takeoff area will automatically and flies to the danger zone. When the UAV is in the danger zone precision area, the rope will be released to the ground using the dropping mechanism. The UAV maneuvers in the danger zone in a spiral and flies 3 times when the rope is coiled. Then, the UAV flies to the safe zone carrying important items ready to be dropped in the safe zone. The dropping mechanism in this area has two servos in the rescue box which are then triggered by a different remote. The pilot takes over the UAV and prepares for landing after missions are completed. There is a fail-safe system to cut the rope if there is a failure in dropping and pulling the rescue box. CAKSA is supported by our campus PENS with 3 best advisors. CAKSA consists of technical and non-technical division. The team was developing a new vehicle that was specifically made for our mission, which is fixed-wing UAV to retrieve important items from danger zone using drop and load system. To support our team doing the research, we have our own laboratory under the auspices of PENS, Politeknik Elektronika Negeri Surabaya. The production and manufacturing processes are carried out in the laboratory itself. Our laboratory equipment is available as follows: electrical and mechanical toolkit, laser cutting, 3D printing, and milling machine to support team continuity. Conducive work environment, efficient teamwork are also one of the factors that support us to complete this mission. CAKSA is practically a new team, but the team members already have experience in developing aerial vehicles by competing in national UAV research competitions. Most of the team members participated in the Indonesian Flying Robot Contest, which is the most prestigious UAV competition organized by the Ministry of Research, Technology and Higher Education of the Republic of Indonesia. Members earn awards in the fields of vehicles technology such as first place in airframe innovation and gold medal for developing Y3 tread rotor airframe innovation. For the hardware work, the team members already have experience in developing hardware components by experiencing for at least 4 years in developing ESC and brushless DC motors for 1 year. Also competing in national competitions. Members are awarded at the first place for developing ESC for fixed-wing and rotary wing types of UAVs, and first place propulsion technology development category. Type of UAV that we use is low-wing and steel configuration. For mechanical work, the members are responsible for design, manufacturing, and renovating of the vehicle, which consists of Philips, Asrorail, and Revki. Philips is focused on designing and analyzing the airframe using CFD and XLFR5, while Asrorail is responsible for material testing and manufacturing process of the vehicle. Then, Revki focuses on repairing and quality checks before and after the flight. There are several software used in the process of vehicle production and manufacturing. Autodesk Inventor 2020 was used for the vehicle designing. Then, the CorelDRAW is used for 2D design plotting. For the analysis tool, we use XLFR5 for wing analysis. The Autodesk Eagle is used for electrical system design. Last, for the manufacturing we use Ultimaker Cura 3D printing and RDCAM laser cutting. Team's knowledge about our UAV is supported by the amount of members' experience in doing the related issues about UAV. They already started their journey in learning and developing through an aerospace community provided by our institution. Refers to that The team has high awareness and enthusiasm in developing the UAV. One of which can be seen from the speed of the team members in responding to the condition of the aircraft during the trial or flight test. For example, during the rescue or repair process for a plane that crashed. In addition, the experience of the members was also proven when designing the airframe, hardware, mechanic, and also vision. CAKSA was formed not only to join the competition, but also to gain new experience. So, we put in so much effort that we have to complete this mission. Started from having a regular meeting every week, trial tests, progression report, etc. Even if our team is new, we hope that our best effort and commitment can make this team more sustainable and grow better in the next generation of aerospace research.
I will explain the electrical system of UAV that we developed. Here is safety board that have a fuse and current breaker to cut off overcurrent and power distribution management to provide power for the main motor and winch mechanism motor. Here is switch button as emergency stop to cut all of the system on UAV. The main components in our vehicles are pickshock for flight control, Holybro pickshock for GPS, and we use propulsion on this vehicle is T-motor 880 kV, Hobby Wing 80 ampere ESG. Absolutely, we use Taranis QX7 and X8R receiver as manual control of the UAV. For detect the zone and move the UAV using Raspberry Pi 4B and regular webcam. Finally, communication on the vehicle, we're using 3DR 915 MHz telemetry.
Let me show you how we develop our UAV. First, we design our UAV in 3D software like Inventor to get the visualization and the precise of our UAV. After that, we use XFLR5 software to know the characteristic of the airfield and also the wing performance like stability, stream, and the pressure distribution. In our UAV manufacture, we use hard foam as the main material that give us a light vehicle, make our UAV cheap and easy to manufacture. And also, we use laser cutting and 3D printing to help us build our mechanism like winch, dropping, and cutting mechanism.
In the vision system, the device used to process the image is a Raspberry Pi 4 and a regular webcam. The image is processed in real time to detect the color and track the midpoint of the zone. We use color detection system to detect the zone because it doesn't use much resource on Raspberry Pi, and we want to get as much FPS as possible. We also use counter detection to get the midpoint of the zone, and so we don't detect other object that doesn't represent the safe or danger zone. After we detect and get the midpoint of the zone, the output is the UAV movement in yaw axis, and we want to get our UAV to the midpoint of the zone so that we can drop the payload. We use C++ library called python.h so we can script a Python program with DroneKit library that connect to Pixel to change the UAV's flight path.
From where I'm standing right now, this is the takeoff area. Our vehicle will take off here and fly to the danger zone autonomously. In the danger zone, our vehicle will drop the rescue box and take the important items that need to be saved. After that, the vehicle will fly to the safe zone while carrying the rescue box, and then the important items will drop safely with parachute. After mission successfully passed, our pilot will take over the vehicle and prepare for landing. Before we go to our mission, let's check for the response of the vehicle.
Response remote check.
Remote check.
Okay. FBWA check.
FBWA check. Okay.
Throttle check.
Throttle check.
Auto check.
Auto mode check. Okay, the response of the vehicle was good. We will next to take off of the vehicle.
UAV ready to take off. Wait a minute, and I'm waiting to respond. Repeat, please. Please wait a minute. Telemetry waiting data response. Okay, copy. Okay, GTS ready. Please fly.
Oh, GCS ready and the vehicle will go to take off. Prepare to change to autonomous mode.
Changing to auto mode. In 3, 2, 1.
The vehicle was successfully take off and now was flying autonomously to the danger zone.
Good, altitude 50.
The vehicle was on 50 altitude.
Go to waypoint 4. Go to waypoint 4.
The vehicle was go to the danger zone.
Waypoint 6. Already dropping. Good.
The vehicle was already dropping.
Please winch.
Then now
Please winch.
the vehicle will winch the rescue box.
Waiting to later 2 times. Next mission is Area 3 UT. Yes. Proof. Selesaikan sampai landing. Oke.
The vehicle now is still in the autonomous mode and still loitering on the danger zone.
Waypoint 8. Waypoint 8. Please using cutting mechanism.
Cutting ke ano? Pilotnya lugur.
Cuttingnya tak ada, pelotnya lugur. Kapan ambil alih itu? Loiter time.
Kapan ambil alih?
Kapan ambil alih? Ini RTL.
After loitering, the vehicle will change to the RTL mode. Then the pilot will take over the control of the vehicle and prepare for the landing.
RTL, pilot can switch to FWA.
Now the vehicle is on the control of the pilot and the pilot was now controlled, so the vehicle can landing safely.
RTL, stay calm. Altitude 15. Bilali. Pilot. Landing safe and all clear.
Now the vehicle is on the FBWA mode.
Altitude. Altitude 34.
Bawa si ini radiasi.
42. Altitude 34.
Di bawah gini.
41. Please landing.
The vehicle still prepare for the landing. And now the landing was doing
Altitude 22.
manually and now heading to the take-off landing area. Now the vehicle is successfully landing safely.
Landing good.